Welcome to Building the Future, hosted by Kevin Horick. With millions of listeners a month, Building the Future has quickly become one of the fastest rising programs, with a focus on interviewing startups, entrepreneurs, investors, CEOs, and more. The radio and TV show airs in 15 markets across the globe, including Silicon Valley. For full showtimes, past episodes, or to sponsor the show, please visit buildingthefutureshow.com.
Welcome back to the show. Today we have Keegan Kirkpatrick. He's the founder and CEO at RedWorks Construction Technologies, Inc. Keegan, welcome to the show.
Thanks for having me, Kevin.
Yeah, I'm actually really excited to have you on the show. I think what you guys are doing is probably one of the most innovative things I've ever heard of. But maybe before we get into all that, let's get to know you a little bit better and start off with where you grew up.
Yeah, well, I'm from Western Washington originally. I'm from a little town called Puyallup.
Okay.
I was pretty much bottle fed on the construction industry. My dad is a finished carpenter and a woodworker who has been building staircases all his life. And since I could walk, I've been either sweeping the shop or sanding and finishing work that he's brought in, or just doing anything I can to help put houses together. And I really got a sense of the industry at a very young age.
Okay. Very cool. But you went to university and you took something that is really quite fascinating. So what did you take and why did you go into that?
Well, you might say I ran as far away from the construction industry as I could when I went to college. I went to Embry-Riddle Aeronautical University. Yeah, I went to Embry-Riddle in Prescott, Arizona, and got my Bachelor of Science in Aerospace Engineering on an astronautics track. My specialty was primarily focused on navigating spacecraft from one planet to the next and how to ultimately propel them. So rocket science at the most fundamental level. When I got out of college, I went to work for a company called Marsden Space Systems. And I was there for about 24 test flights, I think, was what it ultimately shook out to. Some tethered, most of them fixed, doing just basically any type of work you can imagine with the study of rocketry. So once I was done with all that, though, it was in the middle of the sequester. There wasn't a whole lot of work to be had. And I started looking for new opportunities. And I'd really kind of gotten bitten by the startup bug. Okay. And I heard about this challenge that NASA was putting on for their Centennial Challengers. They run those every year. Okay. And the one they'd kind of brought to my attention was the 3D Print Habitat Challenge. Okay. The goal was to figure out a way how to design a habitat on Mars using just not entirely, but at least to some extent, local sources of regolith. So in other words, making buildings out of dirt.
Sure. Now, well, because sending building materials through space to Mars from Earth is an astronomical challenge, never mind probably near impossible or very costly.
Well, yeah, it's very, very costly and not sustainable. If you want to have people survive on Mars for the long term, you have to understand that it, just to give everyone a quick crash course in orbital mechanics, Mars orbits so much further away from the sun that its year is about twice as long as Earth's, which means it takes about twice as long to go around the sun as the Earth does. So for about a year, Mars is actually on the opposite side of the sun as the Earth.
Interesting.
So it would be completely impractical to try to send any type of, so if you have a habitat that's damaged on the surface, it wouldn't make any sense to send something to Mars to resupply. So you need to be able to build on the surface to a degree that you can be self-sufficient.
Okay,
so
interesting.
We decided to kind of take that to its logical extreme, which was to figure out how to design a habitat that could be built entirely using local sources of regolith. And that meant figuring out how to make much more durable substances than what had previously been proposed.
Okay.
And we looked into probably half a dozen different techniques that have been explored for the last several decades.
Okay.
And came upon an idea that NASA had kicked around using, they wanted to essentially put a great big microwave generator on the back end of what would have looked like a giant Zamboni on the moon.
Okay.
And these microwaves would have vulcanized lunar dirt behind it and turned that into a sheet of hard glass. And the idea was you could generate roads doing that. Now we found, after the Habitat Challenge ended, we found a much, much, much more energy efficient solution to achieve kind of the same basic idea of being able to there's a form of artificial vulcanization. So in other words, being able to put the power of a volcano in your hands.
Wow.
To be able to create and 3D print artificial stone objects. So
interesting.
That's what we've been working on. That's what RedWorks' basic idea has been, to figure out a way how to 3D print rock using the same principles of construction that we used for tackling the challenge of how to build on Mars.
Okay. So how does that exactly work? Because to be honest, like, I had to talk to you when I heard about what you guys were doing because I was completely fascinated by it. So how does it work?
Well, we currently have provisional patents out on a technology that we're calling the multi-core induction extruder.
Okay.
So or what we've just come to know as Mickey in-house.
Okay.
Now, Mickey is basically a 3D printer that uses what's called induction heating, which is basically electromagnetism.
Okay.
In a process that we developed that allows us to very, very quickly and very efficiently heat up regolith to a molten state. In a previous test chamber we built, which was just using conductive heating, so what you'd find in like your oven,
okay,
we were able to get a sample of dirt to be basically like a dirt clod rather than just being dirt. In over the space of about 4 hours, and it took a ridiculous amount of energy, and the device itself was the size of a trash can and weighed about 150 pounds.
Okay.
Mickey is the size of a Pringles can.
Wow.
And can do that in about 3.5 minutes.
Wow.
Yeah, from cold soak.
Okay, so how do we explain this so that like anybody can kind of understand this? So how does it work? I buy a piece of land and I'm looking to put a structure on it. Walk me through actually what you guys do to actually build that structure.
All right. So the machine that we'd have is going to be about the size of something you can stick in the bed of a pickup truck.
Okay.
So you drive a rig out, either have a forklift or maybe even just a handful of guys who can then offload the printer itself, which is just going to be, it's just going to be shaped like a big box. It'll look like, your standard desktop 3D printer, just much bigger.
Okay.
You drop that on site and begin excavating material for what would, essentially you're digging your foundation. And you'd be taking that excavated material and then dropping off on a conveyor, which would then be dropped into a hopper on the back end of the printer.
Okay.
That dirt then goes through a feed line, which takes it into the print head itself. And inside the print head is where the magic happens. That's where our proprietary technology, would then heat up the material into a semi-molten state and extruded it out. It would come out kind of like a molten taffy. It's essentially artificial magma. So that would then be laid down layer by layer, just like a plastic 3D printer does.
Okay.
And so by the time the next layer comes on top of it, the layer below it is cooled and is hard enough for the next layer on top of it to be supported. So you're not going to get anything to squish, which is a problem you have with the concrete 3D printing. The next layer ends up kind of crushing the layer before it, and so there's all this deformation, and so you can't create any kind of self-supporting structures as easily as you could using this process.
Interesting.
With us, there's no water, there's no binder. All you need is a steady power supply.
Okay. So how does that kind of work? So, okay, so it's coming off the printer. How do I actually start working with it? Like, do I have to pour it myself, or do I kind of just move the printer along, or how does that kind of work?
Well, the printer will be in a fixed position.
Okay.
So it'll be kind of your own little personal factory. It'll be making bricks, pavers, whatever type of design of modular material you want, and then can push those out as needed.
Okay.
So you can make a brick wall generating your own material completely on site without having to import anything to you, save for, I guess, the mortar.
Okay, so you're basically 3D printing brick by brick, and then I can take the bricks and construct a pathway, a house, whatever I want to do with those bricks, correct?
Exactly. And our long-term plans involve making bigger machines that can make even tilt-up structures, so you can go even beyond that.
What do you mean by tilt-up? Sorry.
Well, this is something we see a lot down here in SoCal, and it's becoming a very popular way to build, has been making these precast molds of about between 6 and 8 feet tall to be able to tilt up and be able to stand up a warehouse, a fairly durable warehouse or building relatively quickly.
Okay.
So we're looking at the possibility of being able to make a machine that would eventually be something like the size of a shipping container that could be able to generate much larger structures like that.
Okay. No, that's actually quite fascinating. So I'm curious then, what types of materials can you actually make with your current process?
Well, right now it's a material that we would call welded tuft.
Okay.
So no one really hears about this, but this is probably one of the most popular forms of building material to be used in the ancient world.
Okay.
The Romans used it extensively to build houses for most of the general population. We often think of the Roman Empire and marble columns and, advanced concrete and all this stuff, but that was for infrastructure projects and for the super rich.
Okay.
For the average, Joe Schmo Roman back in the ancient times,
Sure.
they were living in houses out of welded tuft. Now, welded tuft originally, you could only get it through natural sources. It's made from volcanic ash.
Okay.
And around the Mediterranean, there was a lot of this stuff left over from an explosion of an ancient volcano where Santorini, Greece is today.
Okay.
Now, they mined this pretty much to exhaustion. Our machine essentially allows us to make this artificially, and it's just rock, basically. I can get into the mineralogy all day long, but it's essentially just a strong stone rock.
Sure.
Roughly same material properties as concrete as far as we can see from our own internal internal studies. We're getting ready to do some far more extensive destructive testing with some labs with ASTM certified machines, so we'll be able to have more concrete data, if you'll pardon the horrendously obvious pun.
Sure. No, but the thing that's quite fascinating about that, and you can correct me if I'm wrong, some of those structures from ancient times are very much still around. Like they've survived a lot of years, right? Is that fair to say?
Yes, they have. Yes. Another, probably the most iconic example of welded tuft structures are actually the Easter Island heads, which have been standing out in the middle of the Pacific, taking the worst form of weather that you could imagine for centuries.
Sure.
And they've experienced hardly any erosion at all. So this is an extremely durable material. And, I mentioned the Pacific specifically because we've been in talks with folks in U.S. Naval Facilities Command and Air Mobility Command who've been really interested in what this technology can be used for creating more durable structures in the Pacific region, which is of great concern in the United States defense sector.
Of course.
Now, they're not just thinking of this in terms of going in and, building a forward operations base. They're thinking much more in terms of disaster relief and how we can be able to use what is available on site to be able to stand up new structures when a hurricane or a typhoon comes in and seriously damages the local infrastructure.
Sure.
If you want a very immediate example of this, imagine if after Puerto Rico was devastated by the last hurricanes that passed through there, we could go in with a few of our machines and take the same dirt that just washed away all the roads and use that to stand up at least even just temporary road lines to be able to get to the parts of the island that were otherwise blocked off.
Wow.
You'd be able to get what you can't make on site to the people who need it immediately.
Sure.
That's kind of what I feel is the most disruptive aspect of this technology, is being able to stand up infrastructure immediately where it's needed without having to worry about all the other logistical baggage that modern society needs to be able to get anything done.
Yeah, okay. Interesting. So how long roughly does it take to create a road? I get, what do you go by? How long does it take you to create a mile of road or something like that? What's the unit of measure?
That varies wildly depending on the type of material and the width of the road. Let me put it in a much more a tangible example.
Sure. Okay.
Say you want to make just normal, everyday garden bricks. What you find on houses and the gardens all over the United States.
Sure.
Those standard bricks, we can make. Our machine with a standard 1-inch wide aperture would be able to make about 250, 260 of those per hour is what we estimate, using a machine on our process, using this kind of standard design of machine.
Okay.
Now, those are solid bricks. With 3D printing, it all comes down to the flow rate of the material coming out of the machine, and that means that if you have a more complicated design, it can change the time it takes to make it dramatically. So if you made something like a perfect vertical stack design of a brick that is actually shaped like a honeycomb on the inside of it, You might be able to cut that time down, or it might be a little bit longer, depending on how everything overhangs. 3D printing opens up some very interesting possibilities for how we can change construction, not just making it more sustainable, but how we can change how we can build homes from a pure design side of things. And then there's an even greater opportunity of how we can make homes not just more sustainable, but more livable by being able to 3D print build materials that have conduit lines already pre-laid into them, or much more efficient means of, say, capturing rainwater for more austere parts of the world. I mean, imagine if in a desert, every single home had its bricks set up to where they essentially had their own little piping and water capture systems inside of them, and that could be brought down to reservoirs that could then be connected to everything else in the community. The opportunities for what this technology can do to disrupt the way that we think about building, that's what I'm the most excited to see what we can do in the future.
Sure. Interesting. Okay, so I obviously this is super new and you guys are the first ones doing this, but give us some other ideas of what you guys could do with this technology without obviously kind of giving away your kind of secret sauce, right?
Well, I'll try. So we explored a lot of different opportunities back when we were in the middle of the Habitat Challenge, and we continue to look into different ways on how this can be used. The one opportunity that we've been looking into is then this really changes kind of the math of material cost when you're looking at how to build any kind of home.
Sure.
Because you're not having to import anything to site in the first place. That's the big change here, is that you're ultimately making it possible to build totally locally. But you're also making it possible to build with what would otherwise be a useless byproduct of construction, which is your excavated material. And so the long short of this is that I'm saying is that you can build as much structure as you could possibly want, depending on just how much dirt is available, which is nigh infinite.
Sure.
So imagine if you are, say, you're in Seattle, Washington, and you're trying to deal with the fact that there's a fairly large homeless population coming up in that city these days. In fact, a lot of major urban areas are having that problem.
Sure.
Imagine if you, instead of having to deal with the city council and figure out, we have to build it in an area that's already got low housing prices because low rent housing brings down the cost of homes. Imagine if that wasn't even a problem. Imagine if you could instead build extremely thick-walled, low-rent housing directly by, say, freeways and use them as sound dampeners. You can make the walls as thick as you want to where the occupants wouldn't even notice. You could actually use low-rent housing as a means to be able to improve the value of the area around it, because now you've turned what would otherwise be a detriment to a region just by how real estate prices are calculated. It really shouldn't be that way, but
sure.
The nature of the beast right now.
Sure.
But if you could turn low-cost housing into something that actually adds value to an area, because now not only can you make, say, a low-cost housing development a sound dampener by making the walls so thick to where the occupants don't notice it, you can make the facing walls that are actually facing outward that everyone walking by would see. You could make those extremely decorative because you now have an additive process that can make a very, very intricate design. Where normally, if you were just building with concrete, you have to, get the most bang for your buck, and that's ultimately going to come down to the cost of materials and the cost to get them there and the expertise required to make them. But with 3D printing, it's an automated process that can just manufacture as much as you need on site using our technology.
Right.
You can make whatever structure you wanted. So you could make low-cost housing developments look like very, very intricate, very, very beautiful pieces of architecture. And you'd actually incentivize communities to be able to build more of these structures. You could essentially use this as a means to make eliminating homelessness something that people have a direct, selfish financial reason to want to take advantage of, because it would essentially allow them to be able to raise the property values of everything around them rather than lowering the property values.
Interesting. Yeah. No, I think the whole thing's really quite fascinating to me, right? Because, obviously that is one of the biggest challenges in North America and other parts of the world, right? And it's interesting if 3D printing could be one of the big things that really fixes, or at least adds to fixing that problem globally.
Absolutely. And the solutions are essentially universal across every sector of the industry. For
Okay.
the first people we're planning on selling this to are going to be building some fairly extravagant high-end development.
Okay.
These are the folks who have got kind of the vision and want to take advantage of the technology in the early phases.
Okay.
And these properties have kind of a different problem. For them, it's lowering the cost to get material to site that is the biggest need.
Sure.
When you're trying to build a high-end property, usually you want something that's going to be on a very scenic view. Well,
Sure.
as any builder can tell you, scenic views are often a real pain in the neck to actually get to.
Sure. I can imagine. Yeah.
So our first customer has told us, look, this is a project that's going to be out in Sweetwater Mesa, just outside the hills of overlooking the Bay of Malibu.
Okay.
Absolutely gorgeous vista it's going to be looking at. But the most costly thing to build this project is going to be the cost it's going to get us just to move material to site in the first place.
Sure. Well, and wouldn't
If
it be
they
also
can-
like taking the dirt and like actually digging a hole and taking the dirt or whatever comes out of that hole away too? Isn't that really costly?
Absolutely.
Okay.
You're removing the dirt removal costs entirely. That's universal. That's especially out here in Southern California.
Sure.
If you're in any part of the country that has bad soil contamination, and it's usually directly responsible for really lousy air quality, because anytime someone has to build along those roads or dig up the land to be able to build a foundation to a house, you're kicking a lot of dirt up in the air. It gets kicked up by the wind, and all of a sudden you get people hacking and coughing. I mean, I live out in the Antelope Valley in Southern California, and we have there's a fungus infection out here called valley fever. Basically, any time the wind really kicks up around here, you're hacking and coughing, and you could be laid up for a few weeks with this stuff.
Oh, wow. I
And
didn't know it was
so-
that bad.
And so, well, it's not universal. Not everybody gets it, but it is a
Sure,
risk.
okay.
It's Southern California air quality is no secret.
Yeah, that's fair.
And people tend to cope as best they can. And one of the ways that the state has got everyone to cope is that if you're, say, trying to pave a new road, you're only allowed to do road construction, I think, every mile is how it's set up. So
Oh,
with
okay.
this, you can eliminate any of that kicked up dirt and debris by essentially immediately moving it the moment it's dug up and dropping it into a machine that turns it into an inert block that you can immediately use for construction material. So you're taking something that would be a detriment normally and making it something that has value to not only builders, but to the communities that they're being built on in the first place.
Interesting. Okay. No, this whole thing is really actually quite fascinating. So you mentioned you have some clients already using this technology. Can anybody reach out to you guys and get one of these 3D printers, or where are you guys at with that stage of things?
Right now, we're taking letters of intent and interest.
Okay.
The machine is right now still going through kind of its final cycle of development.
Okay.
We're hoping to have the first public demos ready to go. The advantage of the construction industry, I suppose you could say, is that it's kind of slow moving, and so
Sure.
when we tend to make a deal with someone, the project has got at least a few more months or at least a year out before we actually start breaking ground. So if people want to reach out to us and are interested, we're happy to talk to them.
Okay. So I'm curious, though, to dive a little bit deeper into the process of actually creating the machine, because obviously there's a lot of stuff you could probably use from the 3D printing space, but you mentioned earlier that you had to build some proprietary stuff. So I'm always curious to know, how many kind of prototypes did you have to go through to actually get to where you guys are now, and walk us through that journey of actually building the first few versions of the printer.
It's a hard thing to say how many prototypes we've actually gone through, because it's kind of a ship of theses sort of thing.
Okay.
You end up just taking one part off and replacing it over and over and over again to where you can never quite tell, like, is this the same machine we had 6 months ago?
Okay.
So I would say we've technically had 3 prototypes, but
Okay.
I'd say it's been far more than that, just in terms of the number of iterations we've gone through with the current platform.
Okay.
So this has been a process that's been taken probably over 2 years
Wow.
to actually build and develop everything from scratch. No one's ever developed a heating system like this before to be able to sinter non-conductive materials like regolith. Induction heating has normally only been possible for conductive materials like metal.
Right.
So we developed a way to be able to do it with something like dirt, which sometimes will have a little iron in it, but never enough to really completely center the whole thing.
Okay.
So we've gone through a lot of prototyping on this to be able to get to this phase. And right now, we're in kind of the last mile of that, which is really all about finishing off, not even finishing off, just optimizing the design of the induction system itself, and then mounting that on top of a 3D printing platform.
Gotcha.
Now, this is where we can actually borrow a lot, almost everything from the 3D printing industry itself.
Okay.
We're lucky to where additive manufacturing has been around just long enough now to where most of the major parts have been standardized to absurdity.
Okay.
So for us, it doesn't take too much effort to procure everything we need to be able to build out a 3D printed gantry. And we've got the team that has enough experience working with 3D printing throughout the course of their careers to where building a printer after building the print head is the easy part.
Okay. Interesting.
Yeah.
Okay. So you mentioned your team, and I'm always quite fascinated to know, how did you meet the other people on your team? Because you have a couple other founders, you have some advisors. I'm always curious to know how you met those people.
I was dating someone after hearing about the NASA Habitat Challenge, and immediately, we were just shooting the breeze one day, and I just say, I'd love to get involved in this, but I really don't have the resources. I'd love to find out. And she mentioned there's a little 3D printing shop in Lancaster that does a lot of outreach and training and might have some resources to send out.
Okay.
So I call up Lino Stavoli, the gentleman who ran the shop, and half an hour later, I'm talking to him, and we're just kicking back and forth ideas on what you can do for 3D printing on Mars and how this can be done. And he had a lot of experience 3D printing in the movie business. He was a prop maker. And,
sure.
He's a great guy, and I recommend you take a look at his resume. He's doing some very impressive stuff these days.
All right. Cool.
He's no longer involved in the team, and we were sorry to see him go, but we completely respected how he had to leave.
Sure. Happens, yeah.
But while I was talking to Lino, Paul Petros, who would go on to become our chief design officer, was there doing some work with Lino the same day.
Okay.
And he immediately fell in love with the idea and wanted to get on board. And not long after that, we were connected to Susan Jennings, who was a local environmental compliance expert for the solar industry.
Okay.
So she was he was an engineering geologist.
Okay.
And that was someone we absolutely needed for the challenge, but she also knew Lino and had experience in the 3D printing space and had about 20 years experience in the construction space as an engineering geologist.
Wow. So
the team ended up being put together in, I think, the space of about 20 minutes.
Wow.
And
all from just like a phone call.
Yeah, all from a phone call.
Wow.
Now, for me, this was something that I am still blown away by, because prior to all that, I was busy trying to find work in the aerospace industry in the middle of the sequester.
Okay.
And that was, anyone who's worked in that business will tell you that during that period, it was rough. You're just so used to hearing no every hour of every day, or just hearing nothing.
Okay.
This team was born just from a series of very quick yeses of people wanting to get involved in something just because it sounded like an interesting idea. Now, that was how the team was formed. The company was a bit more of a longer story. After the Habitat Challenge was completed.
Okay.
We made it to the finals, and we, said our piece. We were expecting, like, okay, I guess we'll just kind of go our separate ways for a little while here and see what we can't do to pull together some money, and maybe we'll be able to go, compete in the next phase, whenever that is.
Sure.
Well, NASA took a little while trying to get that next phase put together, and in the time that had to happen, we started getting a lot of phone calls from people who were interested in what we did, and we got invited out to speak at MIT's New Space Age conference. We got invited out to speak at a conference called Dent the Future out in San Francisco, and I got really goaded by about 4 or 5 people I really respected in the industry to go out to a conference called the Space Symposium out in Seattle.
Okay.
Now,
very cool.
At New Space Age, I met who would become the first advisor to RedWorks Construction Technologies, a man by the name of Richard Godwin.
Okay.
Now, Rich had been in the space industry forever, but he's someone who, anytime he sees an interesting project that's even tertiarily related to space, he grabs hold of it with both hands.
Okay.
And he's one of the few guys who's worked in this industry to see technology spun off here on Earth.
Okay.
Now, Rich was the one who connected me to go out to the event in Seattle, and that's where I met Ellen Chang, who was the one who really helped us bring the rest of the advisory group together.
Interesting.
Now, Ellen runs the Lightspeed Innovations Accelerator, and that accelerator program was what helped turn RedWorks from a team of designers to a real company.
Okay.
That was what got us to kind of turn from being a company whose technology was born in space to from a team whose technology was born in space, to a company whose technology had a place to live and breathe on Earth.
Very cool.
And that was really the crucible in which we were able to build our business plan, to connect with our first customers, to connect with the rest of the advisors who would go on to form the lifeblood of the team. So this has been a long journey of where in the beginning it was us just kind of tripping over ourselves to kind of figure out which way was up. And we've really started to hit our stride now. And it's been absolutely a result of the friends and colleagues we've made along the way.
Sure. But it sounds like you didn't start out even wanting to really even start a company. You just wanted to do this NASA challenge. Is that fair to say?
Absolutely. It was literally my thought process when I first heard about the NASA challenge was, that sounds fun.
Sure.
And that was pretty much the same thought process that went through the brain of the founders of RedWorks. Oh, that sounds cool. We'll do that for like 3 months and, who knows what'll happen. And then,
sure.
And yeah, it's, it really was an example of that, you never quite know where life's going to take you. On occasion, something that just sounds like some harebrained little, fun project ends up turning into something that takes up 3 years of your life to build something that might change the world.
No, that's amazing, man. I think that's really great. But I'm curious to know, how did you guys fund this thing? Because you kind of mentioned an accelerator, but how did you guys actually build this thing? Because it probably cost you a lot of time and money to actually get to where you guys are now.
Well, I won't say the dollar amount, but I will say that it was a significant amount of capital, and it was funded largely out of pocket.
Okay. Okay. So you bootstrapped.
And now, not just out of pocket monetarily speaking, I guess you could say it was funded out of pocket and out of garage.
Okay.
The disadvantage to doing any kind of manufacturing-based startup is that you're not building software. You can't just do it off of a computer. You have to actually have hardware on hand.
Right.
The advantage is that when your team is made up of a bunch of tinkerers and pack rats, you tend to have amassed a lot of the stuff you need in the first place. So
go to the attic kind of
thing.
So
Paul, yes. So Paul Petros and Susan both had essentially shops full of 3D printing stuff built up into their own garage. And that was kind of where we built the first RedWorks manufacturing shop, I suppose you could say. It was out of Paul Petros's little outbuilding he had on his home.
That's cool.
It is a stereotype for a reason. I mean,
sure.
When you're trying to get off the ground, you bite and claw and scratch with whatever you got. And we're lucky enough to where all three of us had not only just a lot of experience built up, but a lot of gear that we've managed to, put together over the course of our careers that we were able to bring to the bear. And, yep.
No, I think that's really good advice though, right? Because so many people sometimes think they need to raise millions of dollars and have this huge manufacturing plant. And it just sounds astronomical, right? When in a lot of cases, a lot of you could argue the most successful companies in the history of the planet started in people's garages. Apple, Google, Amazon, all of them, you name them, right? So I think that's really good advice, right?
Right. And, no one's an island. You take you take whatever help you can from friends and family. And we've been lucky to have very, very supportive families during all this too.
Oh, that's awesome, man. So I'm curious to know, what does the rest of 2019 look for you guys? Obviously, you want to start rolling out to more probably states and kind of beyond. But is there anything else that you want to mention that you guys you have on the horizon without giving away too much?
But this is the year we hope to actually get the first demo projects off the ground and really to start showing people what this process looks like face to face. So we're hoping 2019 is going to be a good year for RedWorks, where people will be able to actually start to not only see, but touch what we're trying to bring to the construction industry.
Sure. No, that makes a lot of sense, right? And I'm assuming it's obviously you probably can't live 3D print something at a conference, but you could obviously have some of the materials that you guys have printed at your booth. Is that fair to say?
Most likely. Now, I don't think we'll be bringing anything to the Construction Robotics Forum just yet. Okay. That's not really the format that we have set up.
Gotcha.
But this is not You say we can't 3D print something at a conference. This would not be. Most conferences have asked, like, could you maybe make that work? Is that possible? And I've always had to point out, well, first of all, the machine is probably going to be 6 feet by 6 feet wide.
Okay.
So I don't know how much space you really want to give us. Second of all, the material is pretty hot by the time it comes out of the machine. So I don't know what the safety specs are going to be for just general passerbys.
Sure, fair enough.
Material is safe to touch after 20 minutes, but that's around. I trust that around construction contractors who have read the safety regs and have everything taken care of. Sure. I'm not sure they want to put that in a closed building with a lot of flammable material around it.
No, that makes a lot of sense. No, I think that's great, man. So I'm curious though to know what other advice would you give somebody that has maybe a cool, innovative technology, but they're scared to actually just go for it? Because that's what you guys are doing, essentially.
I got to say, the best advice I have won't be that helpful for a lot of folks.
Okay.
And the advice is this. The hardest step of this entire process is just the willingness to make that first step, to pick up the first phone and actually start calling people and trying to put the thing together. All you got to do, all that it took to really get RedWorks off the ground as to start getting people to actually start calling us in the first place, was something we did purely to promote the team during the challenge. Something that was purely to try to get folks just to be able to call us and see if we couldn't get a little bit more grassroots support going into this Habitat Challenge, which was to just put together a website and put together a web presence. And that the weekend that it took to put that together kind of was the bare bones that it takes to put together a company in the first place. Is to put yourself out there is really all that's doing. And it's not just creating a social media presence, it's really creating a central repository for people to get a hold of you. To build a business, from what I've learned from accelerators and personal trial and error, our team has discovered is really just sitting down and actually doing the work. And for a lot of folks, that's a really scary thing to start on, because the moment you do that, you're off to the races. And you could either crash and burst your teeth on the sidewalk, or you could end up really changing the world. And that's scary for a lot of people. And that's why a lot of folks don't end up going to do this. And there's no shame at all in not wanting to do that. But if you really have a piece of technology, if you have something that is big, that you think the world needs to see, that you want your voice to be heard, you've got to be willing to put yourself out there first and foremost. And that's a cliche thing to be said, but I've learned one thing these last few years, and that's that it turns out those cliches have a lot of truth to them.
No, I think that's really good advice. I know, my story's not as complex as that, I suppose, but I remember somebody saying to me one day that anybody that's ever been successful at anything just decided to go for it one day. And I just kind of looked at them like, wow, that sounds so stupid and simple, but that's really what it is, right? It's just like, you just need to decide to go for it. Just make a call.
Yep. And that sounds like you're saying, it's that easy. Well, what about this, that, and the other thing? And it's like, this, that, and the other thing is what comes afterward.
Yeah.
That, and the other thing is, you just have to start the process. You have to start talking to people. You have to start reaching out to see if you can't find customers, if you can't validate if the idea is going to work or not. And if it doesn't work, you try to change up however the business model has to be. It's all about going through the process. I can't remember who said it for the life of me, but there's a lesson out there called, you have to just learn to love the process, because you're going to get kicked in the teeth for a while, and you just have to learn how to deal with that and bob and weave, and eventually you'll get to where you're trying to go.
Yeah. And
if you don't get to where you're trying to go, you're going to get somewhere, and it's going to be worth it when it's all said and done.
No, I think that's really good advice, right? And I think, and you mentioned it earlier, and I don't know if people picked up on it, it took you guys a couple years to get to where you are now, right? This didn't happen overnight. It didn't happen in a weekend.
Oh, yeah.
Sure, you kicked it off in a weekend, but it took you 2 years to get to where you are now.
Yeah, it's really like, this is just something like on a personal, on just a, if anyone's ever got time, I always recommend them to like Google any major company and just look at when they were actually founded. And you'll notice there's a pretty wide gap for a lot of these companies on when they came into being and when they started to be, when you started to hear about them. So
sure.
It's always a long time. And everybody, there's a reason all these companies come from humble beginnings. It's that if you're not thirsty, you're never going to be able to actually, claw and scrape to be able to get the company to where you need it to be.
No, man, I think that's actually really good advice. And it's interesting. I never thought about just Googling companies that you respect and actually see how long roughly it took you to hear about them from when they're started. I actually think that's really good advice. Actually, that's quite fascinating.
Yeah, it's a common thing in this industry for people to get really kind of hung up on how long it's taken them to get to get the company to a certain phase. And you really start to realize why a lot of startups, just end up kind of dying before they ever end up being known about in the first place. And it really just kind of boils down to people involved just either get discouraged and they just don't want to continue on the journey in the first place. It is a question of persistence. And again, I want to stress, there is no shame in quitting. It's hard. It is not fun for those first few years. You are going to take a lot of hits. And there is nothing. I have a whole new level of respect for people who want to just come in every day and punch the clock. That's not something that I am going to judge anyone for later in life.
No, that's fair. No, I know exactly what you're talking about. I used to think the exact same thing. And then you work at a startup and maybe you have some equity in the startup and you're grinding it out for years. And there's been more times than I can remember, probably even in the last year, that I thought, man, I just need to get a 9-to-5, Monday to Friday job and just do it, right? And just be content with that. And then, I don't know, something just pulls me back and you pick yourself back up, you dust yourself back off, you try some new things and you get a little victory and you just keep going, right? Whatever that means.
Oh yeah. You will be more depressed doing this than you have been at anything else in your life. But once you get the taste for when those little victories come, it's like a drug. You can't walk away from it. It's why, if you ask a lot of these guys in this, kind of world, like, well, what your profession is, that most of them will just say like, well, I'm in startups.
Yeah.
Just because it's the shortest way to describe it, because they're bouncing from, one technology that's working on one industry to the next and changing positions in different companies all over the place. It's a culture that really gets in your blood.
Sure. And the only people that really understand what you're talking about and what you're going through are people that are either going through it or have been through it, right? Like even your probably close friends and family don't really get it. And a lot of them probably think you're crazy. Maybe not in a bad way, but they probably think that. At least some of them. Maybe they won't tell you that, but a lot of them probably think you're crazy. Not it, right?
Well, I've been at peace with the fact that most people have probably thought I'm a little nuts to do this with our team from the get-go. I mean, our team is just used to people thinking we're a little bit kooky, and as a result, we all think we're all completely in sync with one another. It's a good thing to have a team where everyone's just a little bit nuts.
Yeah, but I think you need that, right? I think that's great, man.
Yeah.
But I'm curious. We're kind of coming to the end of the show. Is there anything else that you want to mention before we close out the show?
Well, not at this time, unfortunately. I wish I had more to make announcements for, but this, I think, has been a great show. I really appreciate you bringing me on, and I would love to come back one of these days.
Perfect, man. And I would love to have you back and check in and see where you guys are in 6 months or a year or something like that. But for people that want to get more information about everything you guys are doing, do you want to mention where they can online?
Yeah. Look for us at redworks3d.com. That's REDWORKS 3D.com. You'll be able to find more information about what our technology is, what our team is, our origins, and how to get a hold of us. And that's about the easiest way to get a hold of RedWorks. You can also find us on Twitter, Facebook, and LinkedIn.
Perfect. Well, Keegan, I really appreciate you taking the time of your day to be on the show, and I look forward to keeping in touch with you, and have a good rest of your day, man.
Thank you, Kevin. Back at you.
Thank you. Okay, bye.
Bye-bye.
Thanks for listening. Please visit our website at buildingthefutureshow.com to join the free community, sign up for our newsletter, or to sponsor the show. The music is done by Electric Mantra. You can check him out at electricmantra.com and keep building the future.